Hello everybody, welcome to our presentation. Our team consists of 3 members. I'm Ming.
I'm Zhang.
And I'm Bing.
We come from Hanoi Amsterdam High School for the Gifted in Vietnam. Today, we will elaborate about nanotechnology and our idea for its application in the field of medicine and healthcare. There are 4 parts in our presentation: introduction, experiment, results analysis, and conclusions.
So by definition, nanoparticles or ultrafine particles are defined as a particle of matter at an atomic level whose diameters range from 1 to 100 nanometers, and the term nano is referred to a unit prefix of 1 billion. About the history of development of the field, it all started in 1959 when the scientist Richard Feynman first proposed the term, and in 1981 the scanning tunneling microscope was innovated and is considered the first apparatus ever to support research in the nanotechnology field. In the current society, nanotechnology is playing a dominant role. It is applied in several technology and industrial sectors, for example, transportation, energy, and information technology. It is also integrated in people's daily life with several familiar products such as fertilizers, tires, and cosmetics. Moreover, a multitude of developed nations are right now heavily invested in the field. In terms of medical and healthcare applications, there are several examples of people manipulating nanotechnology. We've got diagnostic techniques, antibacterial treatments, wound treatments, cell repair, and drug delivery, which is also the topic that we're going to discuss more in depth in today's presentation. The detailed process and theoretical explanation of using nanotechnology in drug delivery can be described as, firstly, a healthcare worker will integrate a nanoparticle which contains magnetism into a tablet of medicine. And by doing so, owing to the most definitive characteristic of magnetism to attract objects together, the tablet will be increased in terms of accuracy and speed in reaching the appropriate areas or the organs that is needed to be tackled.
Our project main purpose is the applications of cobalt oxide in drug delivery, and we are going into detail of it. First of all, our experiment's objectives is to manufacture nanoparticle cobalt oxide and apply it to improving the possibility of precisely targeted drug delivery, and also to contribute to tackle medical issues in the long term. Here's our experiment hierarchy. In the first step, we're going to mix 14.04 grams of cobalt nitrate hexahydrate with 100 milliliters of water and stir them using a magnetic stirrer for 30 minutes. In the second step, we're going to make 3.86 grams of sodium hydroxide with 30 milliliters of water and stir them using a magnetic stirrer in 30 minutes. In the third step, we're going to pour the sodium hydroxide with water into the bottle of cobalt nitrate hexahydrate with water, and then precipitates containing nanoparticle cobalt oxide are formed. We centrifuge the solutions at a rate of 4,000 rounds per minute, and then filter and dry in vacuum conditions for 2 hours at 100 degrees Celsius before heating them at 400 degrees Celsius for 2 hours. Here's a video about some real footage of us doing the experiment. This is when we weigh the cobalt nitrate hexahydrate and then stir them with water for 30 minutes. Here's when we weigh the sodium hydroxide and then stir them with water in 30 minutes. Here's the solutions when we pour sodium hydroxide into cobalt nitrate hexahydrate, and then we stir them using a magnetic stirrer for 1 hour. Here's when we centrifuge the solutions at a rate of 4,000 rounds per minute.
Now we would like to show you some experimental results about cobalt oxide's properties. First, this image shows the TEM depiction of the particles. This is the 100 nanometers scale bar. As you can see, these particles are 7 nanometers long in diameter, which we think is the proper size to flow in the bloodstream. Next is the line graph of the mass magnetization of the cobalt oxide example. This is a curved line, so it represents a nonlinear relationship between the magnetization of the particles and the magnetic field strength. These are two example points on the graph. Point A, at the magnitude of 11,000 Erstat, the magnetization is 50 mu per grams. Point B, at the magnitude of 2500 Erstat, the magnetization is 40 mu per grams. So you can see from 0 to 2500 Erstat, the magnetization escalates from 0 to 40. But from 40, it takes a lot more magnetic force for the magnetization to increase.
So subsequently, we've got another line graph which indicates the dynamic light scattering of the liquid after integrated electricity. The red, blue, and green line represents an interval of 30 minutes, 60 minutes, and 120 minutes after the experiment respectively. So from the graph, we can figure out that the nanoparticles have the proficiency of being diluted completely in water, since the discrepancies in terms of size distribution or particles density are insignificant. Here is another comparison of the mixture of nanoparticles in water and in hexane, which is a liquid often found in fuel or diesel oil. In water, the nanoparticles are completely mixed while it was floating at the bottom of the hexane liquid. The phenomenon was generated by the lighter mass of hexane comparing to cobalt oxide nanoparticles, and thus it experienced buoyancy. Therefore, the nanoparticles are capable of traversing through the bloodstream of a human's body without being solidified.
In conclusions, our project demonstrates and interprets the competence of cobalt oxide nanoparticle to transport through human body. We also increase the accuracy of designated conveyance through producing and manipulating cobalt oxide nanoparticles. And finally, we eradicate dilemmas in the medical and healthcare field with instill positive impacts.
The current COVID-19 pandemic, which had caused severe consequences in every aspect, has proved the high possibility of another potential outbreak and emphasized on the importance of medical and healthcare enhancements. Confronting these dire circumstances, we hope that our innovative project will contribute to eradicate the medical struggles that people are having nowadays. That is the end of our presentation, and thank you very much for listening.